Right now, you are traveling through space at over 560,000 miles per hour. You ride on a cosmic merry-go-round so vast. Light itself takes 100,000 years to cross it. We call this spinning island of 400 billion stars our home. We call it the Milky Way, but we have never seen it from the outside. We have never stepped back to witness its true scale. Tonight, we will journey to the edge of our cosmic neighborhood. We will discover everything we thought we knew about size. Our knowledge of distance and our place in space is just the beginning. Astronauts often describe the moment they first see Earth. They peer through the tiny spacecraft window. They search for familiar landmarks on the surface below. Cities that seemed enormous from ground level appear as dots. They are just scattered dots of bright, shimmering light. Mountain ranges that took hours to drive across stretch out. They now stretch beneath them like some wrinkled paper. They squint at the surface below, hoping to spot their hometown. They hope to see their street or maybe even their own backyard. But here is what shocks them the most. They cannot see their own house from that height. They cannot see any house at all. From just 250 miles above the Earth, individual buildings vanish completely from their sight. The resolution of human vision simply cannot capture them. This reveals something profound about the nature of scale. Distance erases all of the fine detail. From the International Space Station, entire neighborhoods disappear. Cities become nothing more than fuzzy patches of light. Countries blend into brown and green smears across the planet. What seemed impossibly large from the ground proves small. It proves impossibly small when viewed from space. Now imagine pulling back even further from our planet. At 1,000 miles up, entire states fade into shapes. At 10,000 miles, the continents start to merge. They merge into a blue marble floating in the darkness. The Earth that felt infinite now fits in your view. This perspective trick works in both ways though. Just as we shrink when viewed from high above, the space around us grows more vast than our minds can grasp. That empty blackness surrounding our tiny planet stretches out. It stretches for distances that make Earth seem like a grain of sand. Consider this strange but accurate comparison. If you could shrink the Earth down to the size of a marble, the nearest star would still be over 4,000 miles away. That marble would sit all alone in an empty space, a space stretching farther than New York to Los Angeles. The sheer isolation of our planet is staggering. This crushing emptiness between objects defines our neighborhood. We exist on a tiny rock surrounded by an ocean of vacuum, a vacuum so vast that even light takes years to cross. But we are not entirely alone in this great emptiness. We travel through it as passengers on something much grander. We ride aboard a collection of stars and of worlds, a collection so enormous that it dwarfs our wildest imagination. We inhabit a massive and beautiful galaxy. However, there is a very significant catch to all of this. Just like the astronauts cannot see their own houses, we face an even stranger problem with our galactic home, the photons that are illuminating this very page. They began a journey that makes every human exploration look small. Light from our nearest stellar neighbor is Proxima Centauri. It left that distant star over 4 years ago. The light that is hitting your eyes right now, it began its journey when different people held different jobs, when different songs were playing on the radio, when the world looked completely different than it does today. This light has traveled through the vacuum of space. It has traveled for 4 long years to reach you. Columbus sailed approximately 4,000 miles from Spain. That seemed like an impossible distance to his contemporaries. They worried that he might fall off the edge of the world. They feared the presence of giant sea monsters and endless storms. 4,000 miles represented the absolute limit of human courage. The light in your room has traveled 25 trillion miles. Let that incredible number settle in your mind. 25 trillion miles is a truly vast distance. If you could drive a car at highway speed, 24 hours a day, 7 days a week, without stopping, It would take you over 40 million years to cover that distance. 40 million years of non-stop driving to reach our neighbor. This reveals the true and staggering scale of our galactic neighborhood. The stars that appear as tiny pinpricks of light in our sky. They are actually massive nuclear furnaces burning brightly. Many of them are much larger and brighter than our own sun. They only look small because of the breathtaking distances. Space stretches so far between the stars that even light, the fastest thing in the universe, requires years to make the crossing. Our galaxy contains roughly 400 billion of these distant suns. Some of them shine just 4 light years away from us. Others blaze from distances of 50,000 light years or more. Each one of them is pumping photons out into space. They are sending their light racing across the great cosmic void. Some of that ancient starlight left its source before humans existed. Some of it began its journey before the dinosaurs walked the earth. When you look up at the night sky, you are seeing a time machine. You are witnessing the past broadcasting itself across space. The stars that you observe might have exploded centuries ago, but their final light is still traveling toward you. It is carrying messages from a cosmos that no longer exists. This creates a very strange situation for all of us. We are living inside of something that is so vast that we can never see all of it at once. We experience our galaxy like ants that are crawling across a clock, able to examine the tiny portions but never able to step back, never able to witness the complete mechanism in its entirety. The light from the far edge of our own galaxy. It has been traveling toward us for 100,000 years. It is carrying information about places that are so distant they might as well exist in a different universe. Imagine holding a single grain of sand between your fingers. You can feel its tiny weight against your skin. You can notice how it barely even registers against your skin. This single grain measures roughly 1 millimeter across. You could easily lose it in the carpet and never find it again. You could blow it away with just a gentle breath. It represents one of the smallest objects you can handle. Now let this tiny grain of sand represent the entire Earth. Every mountain, every ocean, and every single city. Every person who has ever lived is compressed into this speck. A whole world shrinks down to something you could inhale. On this particular scale, what size would your own city be? Your entire neighborhood would become completely invisible. Your own house would disappear from sight completely. Your city, even a major metropolitan area like New York, it would shrink to a microscopic bump on the surface. A bump on the surface of that tiny grain of sand. You would need a powerful microscope just to be able to detect it. But we are only just getting started with this exercise. If the Earth shrinks down to the size of a sand grain, our own moon would become a small pebble floating 20 feet away. The sun would transform into a beach ball positioned half a mile away. Jupiter would grow to the size of a large marble, a marble that is rolling around 3 miles from your position. These distances are already stretching beyond our comfortable human experience. Half a mile feels manageable, but 3 miles requires a decent walk. But the nearest star, Proxima Centauri, now sits far away. It sits 125,000 miles away from you. You could not drive there in a car. You could not fly there in a commercial airliner. You would need a rocket ship just to be able to reach our nearest neighbor. This scale model is revealing something shocking about space. The distances between the objects in our own solar system, which already seem impossibly large, represent practically nothing. They represent nothing compared to the vastness of interstellar space. We are living crammed together in a tiny pocket of warmth and matter. We are surrounded by an emptiness that is so complete that it defies all of our comprehension. Our entire solar system on this particular scale, it can fit comfortably within a circle that is roughly 10 miles across. But the next solar system is 125,000 miles away. The emptiness between the star systems is stretching much further. It stretches 12,000 times further than the entire width of our planetary family. However, even these staggering distances are still very small. They are small compared to the full extent of our own galaxy. If we maintain this same sand grain scale model, our galactic home would stretch 11 billion miles from edge to edge. 11 billion miles is an absolutely immense distance. Light would require 16 hours to be able to cross that distance, even at its incredible speed of 670 million miles per hour. But this comparison is still failing to capture the true strangeness of the galactic scale of things. This is because we have only dealt with distance so far. Right now, as you are sitting and reading these words, you are moving much faster than any human has ever traveled. You are not just spinning with the Earth's daily rotation, a rotation that is carrying you eastward at roughly 1,000 miles per hour. You are not just orbiting around the Sun with our planet, a motion that adds another 67,000 miles per hour to your velocity. You are participating in something that is far more spectacular and violent than either of those familiar motions. Our entire solar system is rocketing through space at a high speed. It is moving at 560,000 miles per hour. This incredible speed is defying all of our human experience. The fastest of our jet fighters can reach roughly 1,500 miles per hour. The supersonic Concorde passenger jet was able to manage about 1,350. Space rockets can achieve maybe 25,000 miles per hour. They do this when they are escaping the Earth's gravity. But we who are sitting perfectly still in our chairs right now, we are traveling through the cosmos at speeds that make all human transportation. They make it all look like leisurely strolls through a park. What is it that is driving this incredible and constant velocity? We are in orbit around something that is truly massive. Our Sun, along with its entire family of planets and moons, and its asteroids and its comets, is wheeling around a gravitational center. A center that is located roughly 26,000 light-years away. We are circling this center like a stone that is whirling on the end of a string, but the string is stretching across distances that light requires. Light requires 26,000 years to be able to traverse. This orbital motion is carrying our solar system on a path so enormous that completing one single revolution, it takes 250 million years to do. 250 million years is a very long time. When our solar system last occupied this same position in space, the dinosaurs had not yet even evolved on our planet. The supercontinent of Pangaea was just beginning to form. Life on the Earth consisted primarily of simple marine creatures. We have completed less than 20 trips around this cosmic center. We have done so since our own planet first formed. The Earth has existed for roughly 4.5 billion years, but we have only managed 18 full orbits of our galaxy. We have done so during that entire vast time span. Our planet is only 18 galactic years old in these terms. This puts our own existence into a new perspective. All of human history, from the first stone tools to space exploration, it has all occurred during less than 1% of a single galactic orbit. Rome rose and fell, and civilizations emerged and vanished. Entire species have evolved and have gone extinct. All of this has happened while we have moved through just a tiny slice of our own cosmic neighborhood in the galaxy. But what exactly is it that sits at the center of this vast orbital dance? What massive object could possibly possess enough gravitational pull to drag our solar system and hundreds of billions of other stars, drag them around in this slow and stately procession? The answer to this question involves something so extreme that it is able to warp space itself. For most of human history, we believed that we occupied the center of all of creation in the universe. The Earth was sitting motionless while the Sun and the Moon and the planets and all of the stars were wheeling around us. They were wheeling around us in a series of perfect circles. This idea made a great deal of sense to our ancestors. We could not feel any motion at all beneath our feet. We could observe the celestial objects rising and setting like clockwork. Obviously, they reasoned everything else must be moving. Everything must be moving while we remain stationary at the cosmic center. This comfortable assumption lasted until the astronomers developed better instruments, and they started to measure things much more carefully. First, they discovered that the Earth is orbiting the Sunday. It is orbiting the Sun rather than the reverse. This particular demotion stung our collective ego, but at least our Sun might still be occupying the center of something that was much larger in scale. Then, in 1917, astronomer Harlow Shapley made a discovery that shattered even this modest hope for us. Shapley was studying what are known as globular clusters. These are dense balls of ancient stars that are hovering around our galaxy like fireflies around a campfire. He was able to measure their distances and map their positions in space. What he found in his data shocked the scientific community. These ancient stellar clusters did not center themselves around our solar system. They did not even center themselves around our local region of space. Instead, they were all clustered around a single point, a point that was roughly 30,000 light-years away from us. It was in the direction of the constellation of Sagittarius. Our solar system was sitting far out toward the edge of this vast collection. It was like a small cabin in the suburbs of a major metropolitan area. We were not at the center of our galaxy at all. We were not even close to being at the center. We were inhabiting the galactic equivalent of a rural outpost. This discovery was able to reveal that we are living inside something that is much larger than anyone had ever imagined. Shapley calculated that our galaxy is stretching roughly 100,000 light-years. 100,000 light-years from one edge to the other. Our solar system sits about 26,000 light-years from the galactic center. This is placing us much closer to the outer edge than to the middle. If our galaxy were the size of a pizza, we would be living somewhere out near the very crust. We would definitely not be enjoying a prime location near the center where all of the good toppings are concentrated. This particular positioning actually benefits us tremendously, though we did not realize it at the time of the discovery. The galactic center turns out to be a very violent place, a violent and hostile environment that is filled with intense radiation, and it is filled with gravitational chaos and exotic phenomena that would sterilize any of the nearby planets. Our suburban location is providing a quiet and stable environment, an environment where complex chemistry is able to evolve over billions of years. But Shapley's revelation also raised a brand new question. If we are orbiting something that is 30,000 light-years away, what could possibly be massive enough to gravitationally bind all of the stars, bind hundreds of billions of stars into this enormous spinning structure? The answer to that question would not come for many decades. And when it finally did, it would prove to be stranger than anyone had ever expected it to be. Measuring the width of our galaxy presented the astronomers. It presented them with an impossible challenge to overcome. How do you measure something when you are trapped deep inside of it? How do you determine the size of a forest when you are standing between the trees? How do you map the borders of a city when you cannot leave the city limits? Astronomers were facing exactly this problem when they tried to figure something out. When they tried to figure out how big our galactic home actually was. Harlow Shapley was able to solve this puzzle by using a clever trick. He could not step outside of our galaxy to measure it directly, so instead he mapped the locations of the globular clusters, those dense balls of ancient stars that are orbiting our galactic center. They are like distant streetlights that are marking the way. Shapley knew that these globular clusters were surrounding our galaxy. They were surrounding it in a roughly spherical halo. If he could measure the distances to enough of these clusters and then plot their positions in a three-dimensional space, he would be able to outline the invisible boundaries of our galactic home. The clusters would be acting just like survey markers. They would be defining the edges of something that was too large to see directly. This required him to solve another seemingly impossible problem: the problem of measuring the distances to objects that are tens of thousands of light years away. Shapley was able to accomplish this by studying a certain kind of star. He was studying Cepheid variable stars, which are special. They are special stars that are pulsing brighter and dimmer in a predictable pattern. Amazingly, the rate at which these stars are pulsing, it directly relates to their actual intrinsic brightness. A Cepheid that is pulsing slowly is shining intrinsically brighter. It is brighter than one that is pulsing much more quickly. This relationship was able to give Shapley a kind of a cosmic ruler. When he was observing a Cepheid variable star in a cluster, he could time its pulsing pattern to determine how bright it actually was. Then he could compare that true brightness to how bright it appeared from Earth. The difference between the actual brightness and the observed brightness. It was able to reveal the distance to the star. This is because more distant objects will always appear to be dimmer than the nearby objects of the same intrinsic brightness. Using this powerful technique, Shapley was able to measure the distances to dozens of globular clusters that are scattered around the sky. When he plotted all of their positions in three-dimensional space, a clear and distinct pattern began to emerge from his data. The clusters were outlining a vast and spherical region, a region that was roughly 100,000 light-years across. Our own solar system was sitting nowhere near the center of this sphere. Instead, we were occupying a position that was about two-thirds of the way toward the outer edge of the sphere. This measurement shocked everyone, including Shapley himself. 100,000 light-years exceeded every single previous estimate. Every previous estimate of the galactic size by enormous margins. Most of the astronomers had assumed that our galaxy might be smaller. It might be stretching a few thousand light-years across. This would be comparable to the distances between the nearby stars. Instead, Shapley was able to reveal that we are inhabiting something that is truly cosmic in its overall scale. 100,000 light-years means that light which is traveling at 670 million miles per hour. It requires 100,000 years to be able to cross from one side of our galaxy to the other side. His measurement has held up remarkably well over time. Modern techniques have refined his estimate just slightly, but Shapley got the basic scale of our galaxy exactly right. He did so by using instruments that seem primitive by today's standards. However, Shapley's globular clusters were only mapping the visible boundaries of our own home galaxy. Something that is completely invisible is surrounding us. We cannot see it and we cannot touch it. We cannot detect it with any of our normal instruments. Yet this mysterious substance is outweighing everything that is visible. It is outweighing it by a ratio of roughly 20-1. The stars, the planets, the gas clouds, and the dust particles, and all of the normal matter that we can observe. All of this only accounts for about 5% of our galactic home. The other 95% of it is consisting of something that we now call dark matter in our theories. How do we know that this invisible matter exists at all? How do we know if we cannot detect it directly with our instruments? It is the same way that we know that the wind exists. The wind exists even when we cannot see the air. We are able to observe its effects on all of the other things. The stars that are in the outer regions of our galaxy, they are orbiting the galactic center much too quickly. They are moving so fast that they should be flying apart. They should be scattering into the intergalactic space. They should be like mud that is flying off of a spinning tire. The gravitational pull of all of the visible matter in our galaxy, it cannot provide enough force to be able to hold these stars, to hold these speeding stars in their stable orbits. Something else must be out there, something that is massive enough to generate the additional gravitational pull, the pull that is required to keep our galaxy intact. This invisible mass is forming a roughly spherical halo, a halo that is all around our own home galaxy. It is extending far beyond the visible star-filled disk. Recent measurements have suggested that this dark matter halo, it is stretching nearly 2 million light-years across in size. 2 million light-years is an absolutely immense distance. This means that the true boundary of our galactic home, it is extending 20 times further than the visible stars. Most of our own galaxy is consisting of empty space that is filled with invisible particles. Particles that we do not yet understand at all. Think of it in this particular way to understand the scale. If our visible galaxy was a flashlight beam in a dark room, the dark matter halo would be the entire room itself. The entire room that is surrounding that small cone of light. We are living inside of the beam of light, completely surrounded by vast volumes of invisible mass. Mass that we can only detect through its gravitational influence. This dark matter does not behave like normal matter. It does not emit any light, and it does not absorb any light. It does not interact with electromagnetic radiation at all. Dark matter particles are able to pass right through normal matter. They can pass through as if it was not even there at all. Billions of these dark matter particles are flowing through your body. They are flowing through you every single second without any interaction. Scientists have estimated that there is a huge amount of this, roughly 600 billion to 3 trillion times the mass of our Sun. This amount of dark matter is filling the halo around our galaxy. This invisible mass is shaping the structure and the evolution of our galactic home in ways that we are only just beginning to be able to understand. The existence of dark matter is raising profound questions about the very nature of our reality. Most of the universe is consisting of something that we cannot see, something that we cannot touch or directly detect in any way. We are inhabiting a cosmos where the familiar matter, the matter that makes up the stars, the planets, and ourselves, it is representing just a tiny minority component of the whole. But even this vast invisible halo has its own boundaries. And beyond those boundaries lies something that is even more mind-bending. In 1977, humanity launched 2 robotic explorers. They were launched toward the outer planets of our solar system. Voyager 1 and Voyager 2 are representing the fastest objects. The fastest objects that humans have ever sent into deep space. They are racing away from our solar system at a high speed, at roughly 38,000 miles per hour. This is fast enough to be able to cross the United States. To cross it in less than just 5 minutes of time. These spacecraft have now traveled further from the Earth, further than any other human creation has ever gone. They are carrying messages to possible alien civilizations, and they have returned some stunning images of the distant worlds. But their incredible speed, which was achieved through careful gravitational assists from multiple different planets in our solar system, it is still proving to be pathetically inadequate for galactic travel. At 38,000 miles per hour, Voyager 1 would require a long time. It would require 173,000 years just to reach our nearest neighbor. Our nearest stellar neighbor, if it were actually headed in that direction. 173,000 years is a very long time. This time span is exceeding the entire span of human civilization. It is exceeding it by a factor of more than 10. Agriculture, writing, cities, empires, and industry, and space travel have all developed during a much shorter time, a time period that is much shorter than the journey to our closest star. But reaching the next star over is representing barely the first step in any kind of galactic exploration to be able to cross the full width of our own galaxy. It would require the Voyager 1 spacecraft 1.7 billion years. 1.7 billion years of constant and uninterrupted travel. This time span is dwarfing not just all of human history, but the entire history of complex life here on our planet. When Voyager began such a hypothetical journey, the most advanced life forms on our planet would have been simple bacteria, and they would have been simple algae in the oceans. Multicellular organisms had not yet even evolved on our planet. Animals did not exist, and plants did not exist. The Earth's atmosphere at that time contained almost no oxygen during the billion-plus years that would be required for Voyager, required for it to be able to cross our own home galaxy. Life on our planet has evolved from single cells to the complexity of our human civilization that we have today. This puts the galactic distances into a biological perspective, the evolution from the microbes to the mammals and the minds. It takes less time than crossing our cosmic neighborhood. It does so at the fastest speed that our technology can achieve. This calculation is assuming that the Voyager spacecraft, it could somehow be able to maintain its speed indefinitely, without ever running out of its fuel or breaking down, or colliding with anything in its path at all. In reality, both of the Voyager spacecraft will go silent. They will do so within the next decade as their power sources decay. They will continue to be coasting through the vastness of space. They will do so as dead hunks of metal and plastic, but they will never be able to report back to us about what lies in the great darkness that is between all of the stars, the vast emptiness that is between the stellar systems. It is creating an almost perfect and complete vacuum. Voyager is encountering less than one single atom per cubic centimeter. It is doing so in the space that is between the stars. This is representing a vacuum that is much more complete than anything that we can create in our laboratories. The spacecraft is traveling through regions that are so empty that it might not encounter another solid object, not for many millions of years of its journey. This emptiness is what is defining the structure of our galaxy. The stars are clustering together in a flat disk, but enormous spaces are separating each point of light from its many different neighbors. However, our galaxy is containing much more than just individual stars, more than just stars that are scattered through the empty space. Our galaxy contains more stars than there are grains of sand on all of the beaches of our planet Earth. 400 billion stars are shining within the boundaries of our own cosmic neighborhood in the galaxy. 400 billion is a number that exceeds our human comprehension. If you were to count one single star every second, 24 hours a day, it would take you a very long time. It would take you over 12,000 years to count them all. If every single person that is currently alive on the Earth, if they took responsibility for counting a different group of stars, each person would need to be able to count roughly 50 stars. They would need to do this to complete the entire census. These stars are coming in an astounding variety of sizes, and of colors, and of different ages as well. Some of them are shining a bright blue-white color, and they are burning through their nuclear fuel in just a few million years. Others are glowing a deep red color, and they are sipping their fuel, sipping it so slowly that they will continue to shine for billions of years. Hundreds of billions of years long after our own sun has died. Some of the stars are containing barely enough mass to sustain fusion, while others are packing dozens of times more matter than our Sunday. They are packing it into incredibly dense and hot stellar cores. The diversity of these stars is extending beyond just their size, and their temperature differences as well. Some of the stars are existing in pairs orbiting each other. They are orbiting each other in elegant gravitational dances. Others are clustering together in groups of dozens or hundreds. They are forming stellar cities where the intense radiation and the gravitational interactions are creating exotic phenomena. Some of the stars are pulsing with some very regular rhythms. They are acting just like cosmic lighthouses that are sweeping their beams of light across the vastness of space. Among these 400 billion stars in our galaxy, at least 100 billion planets are orbiting in the habitable zones. the habitable zones where liquid water could possibly exist. 100 billion potentially habitable worlds are scattered. They are scattered throughout our own galactic home. Some of these planets might be harboring some form of life. Some of them might even be hosting advanced civilizations. Some of them might contain intelligence that is advanced enough to be contemplating the very same questions. The very same questions that we are exploring right now. The oldest of the stars in our own galaxy were formed. They were formed over 13 billion years ago. They were formed when the universe itself was very young. These ancient suns have been able to witness the entire history of all of cosmic evolution, from a time when the heavy elements barely existed at all, to the current epoch of the rocky planets and the complex chemistry. Some of the planetary systems that are around these old stars, they could have been able to support life for billions of years longer than the Earth has existed. This vast stellar population is not distributing itself randomly. It is not random throughout our own home galaxy. The stars are organizing themselves into a flattened disk, a disk that is roughly 1,000 light-years thick, and it is 100,000 light-years across in its diameter. Our own solar system is sitting embedded within this disk. It is about 26,000 light-years from the galactic center. From our position that is within this galactic disk, we are able to see the concentrated glow of billions of stars. Billions of distant stars when we are looking toward the galactic center. This is what is creating the bright band of the Milky Way, the bright band that is arching across our own night sky. We are looking edge-on through the flat plane of our galaxy. We are seeing the combined light of countless different suns that are too distant for us to be able to resolve individually. But these 400 billion stars are representing just the beginning of our own galactic inventory. Our entire galaxy is spinning like a vast cosmic pinwheel, but its rotation is following rules that are unlike anything that we are able to experience here on our planet. When a record is spinning on a turntable in your home, all of the points on that record will complete one revolution. They will do so in the very same amount of time. The center and the edge of the record are rotating together. They are maintaining their relative positions as they spin, but our own galaxy is behaving very differently from this. The stars that are closer to the galactic center, they are orbiting much faster than the stars that are farther out. It is like the runners that are on a circular track, where the inside lanes are moving at higher speeds than the outside lanes. Our own solar system is positioned roughly 26,000 light-years. It is 26,000 light-years from the galactic center, and it requires 250 million years to complete one orbit. 250 million years is a very long time. Astronomers are calling this vast time span a cosmic year, and it is providing a useful measure for the galactic timescales. Since the Earth was formed 4.5 billion years ago, our planet has only completed 18 trips around the galaxy. Just 18 of these cosmic years in its entire history. All of the Earth's history from the formation of the first rocks to the present moment is spanning less than 20 galactic rotations. Consider what this means for the history of life on our planet. When the Earth completed its previous orbit around the galaxy, 250 million years ago, the supercontinent of Pangaea, it was just beginning to break apart at that time. The dinosaurs had not yet even evolved on our planet. The most advanced life forms at that time were primitive reptiles and different kinds of amphibians. Mammals did not exist yet, and flowers did not exist yet. Even the grass did not exist on our planet at that time. The entire age of the dinosaurs from their first appearance to their extinction 65 million years ago, it lasted for about 1/4 of a single galactic year. Human civilization has existed for less than 1/10,000th of a single cosmic year in our history. If our galaxy's history was compressed into a single Earth year, human civilization would represent just the last few seconds. the last few seconds before midnight on December 31st. This slow rotation is creating some interesting consequences. Consequences for all of the stellar neighborhoods in our galaxy. The stars that are currently sitting near each other in space. They will begin to drift apart over the cosmic time. The patterns of the constellations that seem so permanent from our own human perspectives on Earth, they will completely rearrange themselves within a few million years. Our own sun's orbital path is carrying us up and down. It is carrying us through the galactic disk as we circle the center. We spend about 33 million years above the disk's central plane. Then we dive down to spend 33 million years below it. This is creating a gentle bobbing motion that takes a long time. It takes roughly 66 million years to complete one cycle. Some scientists have suggested that this vertical oscillation, it might be correlated with the mass extinction events on Earth. When our solar system is passing through the disk's central plane, we are encountering denser concentrations of gas and dust. This could be disrupting the outer reaches of our solar system, and it could be sending comets tumbling toward the inner planets, the stars that are in the different parts of our galaxy. They are all orbiting at very different speeds from each other. This is creating a complex pattern of stellar motion, a pattern that astronomers are calling differential rotation. At the exact center of our own home galaxy, there is lurking something that is so massive and so dense that it is able to warp both space and time. Sagittarius A times is the supermassive black hole at our galactic core. It contains the mass of 4 million of our suns. This mass is compressed into a region that is smaller than our solar system. 4 million suns is an absolutely immense amount of mass. This gravitational monster is exerting such a powerful attractive force, a force that it is able to hold our entire galaxy together. It is binding 400 billion stars into a single rotating structure. A black hole that is this massive is creating effects that are defying our normal everyday experience. Near its event horizon, the boundary beyond which nothing can escape. Space itself is being stretched and twisted into impossible shapes. Time is running much slower there than it does here on Earth. Clocks would be ticking more slowly near this black hole. They would be ticking more slowly than they do in your own living room. We cannot see the black hole directly with our telescopes. This is because it is trapping the light along with everything else that ventures too close to it. But we are able to observe its effects on the nearby objects, the stars that are orbiting very close to Sagittarius A*. They are reaching speeds of over 3,000 miles per second. They are doing this as they whip around the invisible gravitational anchor. 3,000 miles per second is an incredible speed. These stars are completing their orbital periods in just a few years, not in centuries or in millennia like other stars. The black hole is occasionally feeding on the material around it. This happens when gas clouds or even entire stars wander too close. They wander too close to its immense gravitational grasp. As the material is spiraling inward toward the event horizon, friction is heating it up to temperatures of millions of degrees. This superheated material is glowing brilliantly in X-rays, and it is glowing in radio waves before it disappears forever. It disappears beyond the point of no return of the black hole. Recent observations of this black hole have revealed something. Sagittarius A times is spinning at nearly the maximum rate possible. The maximum rate possible for any black hole in the universe. It is rotating so fast that it is dragging space itself. It is dragging space along with its own rotation. This is creating a phenomenon that is called frame dragging, a phenomenon that was predicted by Einstein's theory of general relativity. This central black hole likely formed very early in our galaxy's history. It grew from a much smaller seed by consuming gas and dust, and it consumed many stars over billions of years of time. As it grew larger and larger, its gravitational influence expanded, This allowed it to be able to capture and organize the matter that would eventually become our own spiral galaxy, the region that is immediately surrounding our galactic center. It is resembling a kind of a cosmic war zone in its nature. There is intense radiation, and there are strong magnetic fields, and there is a great deal of gravitational chaos in that region. All of this is creating conditions that are hostile to planet formation, and it is hostile to the evolution of biological life. Dense concentrations of massive stars are living fast and dying young. They are exploding as supernovas that are adding even more energy to an already very violent environment. Despite sitting 26,000 light-years away from this mayhem, we are still able to feel the black hole's gravitational influence. It is providing the central anchor point around which our solar system orbits. It orbits along with all of the other stars in our galactic neighborhood. But Sagittarius A times is representing just one single component, one component of a much larger and more complex galactic structure. We are facing a problem that no other astronomers in the universe share. We are living inside of the very thing that we are trying to study. Every other galaxy in the entire universe can be observed. It can be observed from the outside, and it can be photographed in its entirety and mapped from a comfortable external vantage point. We alone must be able to piece together the structure of our cosmic home. We must do so from the clues that are gathered while we are trapped within the boundaries of our own home galaxy. Imagine trying to map out the layout of a vast city. While you are locked inside of a basement apartment with no windows, you could be able to send some observers to different street corners. They could report back to you what they are able to see, but you would never be able to step back to view the whole area, the whole metropolitan area from high above the city. This is a description that describes our situation exactly. When we are looking toward the center of our own galaxy, we are peering through the flat disk that contains most of the stars and the dust of our galactic home. Thick clouds of interstellar material are blocking our view. They are blocking it just like a thick fog would. They are absorbing the visible light before it can reach our telescopes. We can only see a few thousand light years through this cosmic smog. We can do so before everything disappears into the darkness. Radio waves and infrared light are able to penetrate this galactic fog. They can do so much better than the visible light can. This is allowing us to be able to probe deeper into our galaxy's structure. But even these longer wavelengths are not able to give us the clear view, the clear and comprehensive view that other astronomers have. The astronomers that are studying the external galaxies. Our edge on perspective is creating another problem. When we are looking along the plane of our own galactic disk, we are seeing the combined glow of billions of distant stars. These stars are blending together into the bright band that we call the Milky Way. The individual stars are becoming impossible to distinguish. They are impossible to distinguish at very large distances. We are losing all sense of the three-dimensional structure. We are losing all sense of the depth of our own galaxy. This viewing challenge has led to some spectacular discoveries. This is because we are sitting inside of our own galaxy. We are able to study the individual stars much more closely. We can do so than astronomers who are observing external galaxies. We can be able to measure the properties of the stellar neighborhoods. We can map the chemical composition of the gas clouds, and we can detect the planets that are around the nearby stars. We can do so with a precision that would be impossible from outside. Recent space missions have begun to overcome some of these limitations. The Gaia spacecraft has been able to measure the precise positions and motions. It has done so for over 1 billion of the stars in our galaxy. This is creating the most detailed three-dimensional map, a map of our own galactic neighborhood that has ever been attempted. These measurements are revealing the patterns of the stellar motion, patterns that are helping us to understand our galaxy's overall structure, and they are helping us to understand its long history. Still, we will never be able to enjoy the luxury of stepping outside. stepping outside of our own galaxy to photograph it from a distance. We must remain forever trapped within our own cosmic home. We are like creatures that are living their entire lives inside of a vast and grand mansion. We are able to explore the individual rooms of the mansion, but we are never able to appreciate the building's complete architecture. This limitation is what is defining the human condition. It is defining it on the vast cosmic scales of the universe. We are inhabiting something that is far grander than ourselves, yet we can never fully comprehend its beauty or its complexity. This is because we cannot escape our position that is within it. We must be able to piece together our galaxy's appearance. We must do so from the fragments and the clues that we can gather. We are like archaeologists who are reconstructing an ancient temple, reconstructing it from the scattered stones that they can find. Despite this limitation, we have succeeded in mapping our home. We have done so with a remarkable degree of accuracy. Through our careful observations and our computer simulations, and our comparisons with the external galaxies, we have learned that we are inhabiting one of the universe's most magnificent structures. Our galaxy is spanning over 100,000 light-years. It is containing 400 billion different stars, and it is participating in the grandest cosmic dance imaginable. We are the citizens of infinity in this vast cosmos. We are the residents of a cosmic city that is beyond all human comprehension. We are forever seeking to understand our own place. Our own place in this vast and grand architecture of the universe. The beautiful spiral arms that are defining our galaxy's appearance. They are existing as phantom structures in a way. They are more like cosmic traffic jams than they are solid objects. Most people are imagining the galactic spiral arms. They are imagining them as fixed features like the arms of a giant pinwheel, a pinwheel that is rotating through the vastness of space. But this particular picture has proven to be completely wrong. The spiral arms that we are observing are containing no permanent matter. Instead, they are representing zones where the stars and the gas, where they are temporarily crowding together before they disperse. They disperse back into the general galactic disk of our galaxy. Think of the rush hour traffic that is on a busy highway. The cars are bunching up around the construction sites, or they are bunching up around the accidents on the road. This is creating dense concentrations that are moving much slower. They are moving much slower than the individual vehicles are. From an airplane, these traffic jams are looking like solid structures that are crawling along the length of the roadway. But no individual car is remaining trapped in the jam permanently. The cars are constantly entering the crowded zone from behind, and they are exiting the crowded zone ahead of the jam, while the jam itself is maintaining its shape and its location. Our own galaxy's spiral arms are working in exactly the same way. Individual stars are orbiting the galactic center at their own speeds. They are occasionally passing through the spiral arms. They are doing so just like cars are passing through the traffic jams. The arms themselves are representing waves of compression that are sweeping around our entire galaxy. They are creating some temporary concentrations of the stars and of the gas and the dust in our home galaxy. These compression waves are triggering some intense episodes of star formation as they are squeezing the gas clouds. They are squeezing them to much higher densities than normal. New stars are igniting in brilliant blue clusters of stars. They are illuminating the spiral arms and making them visible across the vast distances of our own galaxy. The brightest and the most massive of these stars. They are burning out very quickly, and they are dying. They are dying as spectacular supernovas before they can drift away. They drift away from their birthplace in the spiral arms. This is what is creating the illusion that the spiral arms, that they are containing permanent populations of young, bright stars. Our own solar system is currently sitting between two major spiral arms. It is sitting in a smaller spur that is called the Orion arm. we have completed our last passage through a major spiral arm. We did so roughly 50 million years ago in the past, and we will not be encountering another one for approximately 10 million more years during our travels that are through these spiral arms. Our own solar system is experiencing higher concentrations of gas, dust, and radiation. This might be influencing the Earth's climate and its biology. The spiral structure itself is rotating around our galaxy. It is doing so much slower than the individual stars are orbiting. This is what is creating the differential motion that is allowing the stars to pass in and out of the spiral arms. It happens over the long cosmic timescales of our galaxy. If the spiral arms were rotating at the very same speed as the stars, they would be quickly winding up into some very tight spirals, and they would be disappearing within a few 100 million years. Scientists are still debating exactly what is creating and maintaining. What is maintaining our galaxy's own spiral structure? Gravitational interactions with the smaller companion galaxies. They might be pumping energy into the disk of our galaxy. This would be sustaining the compression waves over billions of years. Alternatively, the central bar-shaped region of our galaxy. It might be driving the spiral patterns through complex gravitational dynamics. Recent observations of our galaxy have revealed something. Our spiral arms are showing a remarkable degree of complexity. They have branches, spurs, and gaps that are changing over time. They are changing over the timescales of tens of millions of years. But these spiral arms, as impressive as they may appear, they are representing just the most visible component of something that is far more vast and mysterious. Our own galaxy is not traveling alone through the cosmic dark. When you are able to zoom out far enough to see beyond our galactic boundaries, a very surprising and beautiful sight begins to emerge. Small companion galaxies are orbiting all around us. They are like moths that are circling a bright campfire. These cosmic satellites, though they are dwarfed by our 400 billion star collection, they are containing millions or even billions of stars of their own. They are dancing in attendance on our massive galactic home. They are bound by the gravitational threads that are stretching across hundreds of thousands of light years of space. The two most famous of these companions are shining prominently. They are shining in the skies of the southern hemisphere. The large and the small Magellanic Clouds are appearing as fuzzy patches of light that are looking like detached pieces of our own Milky Way galaxy in the sky. Early ocean navigators were able to use these celestial landmarks. They used them for their navigation on the open seas. They were never suspecting that they were actually gazing at entire galaxies in their own right in the sky. The large Magellanic Cloud is containing roughly 10 billion stars, and it is sitting 160,000 light-years away from us. The small Magellanic Cloud has about 3 billion stars, and it is lying slightly further out at 200,000 light-years. These distances are placing both of these galaxies well beyond the edge of our own visible stellar disk in our galaxy, but they are still well within our extended dark matter halo. These companion galaxies are not orbiting peacefully, though. Our own massive gravitational influence is distorting their shapes. It is stretching and warping their stellar populations. It is doing so just like taffy that is being pulled. Long streams of gas and stars are being torn away. They are being torn away from both of the Magellanic Clouds. This is creating vast ribbons of matter that are trailing behind them. They are trailing behind them as they are circling our own galactic center. But the Magellanic Clouds are representing just the largest members of a much more extensive galactic family. Over 30 of the smaller satellite galaxies are populating our local neighborhood. Most of them are containing only a few million stars each. These tiny galaxies are bearing some very exotic names like Draco, Sculptor, and Fornax, for example. They are named after the constellations in which they appear. they appear from our own perspective here on the Earth. Many of these satellite galaxies are so incredibly faint, so faint that we have only discovered them very recently. We have used sensitive electronic detectors to be able to pick out their dim glow against the background of all the other stars. Some of them are containing so little of the normal matter, so little that they are consisting almost entirely of dark matter. This is making them nearly impossible to detect. Despite them containing the mass of millions of our suns, our own gravitational influence on these companions is proving to be devastating over the cosmic time. As they are orbiting through our extended and vast halo, the tidal forces are gradually stripping away their outer stars. This is feeding our own galaxy's growth over time. We are slowly cannibalizing our smaller cosmic neighbors. We are growing larger at their own expense in a process that has been continuing for billions of years. This galactic cannibalism is revealing something profound about how the large galaxies like our own how they form and evolve over the cosmic timescales. The galaxy that you are able to see in the night sky, it is representing only the bright core of something that is vastly larger and almost entirely invisible. Recent measurements of our galaxy have revealed that our dark matter halo, it is extending nearly 2 million light-years from our galactic center. 2 million light-years is an absolutely immense distance. This means that the true boundary of our own galactic home, it is stretching 20 times further than the visible edge of our own stellar disk in our galaxy. Most of our own galaxy is consisting of empty space that is filled with some form of invisible matter that we can only detect through its gravitational effects. Imagine our own visible galaxy as being a cherry pit that is sitting in the center of a basketball. The cherry pit is representing the 100,000 light-year disk, the disk that is containing all of our familiar stars and all of our gas and all of our dust as well. The basketball is representing the true extent of our galactic domain, a domain that is filled with the mysterious dark matter particles that are not interacting with anything except for gravity. This invisible halo is containing at least 10 times more mass than all of the visible matter in our galaxy combined. 600 billion to 3 trillion solar masses worth of dark matter. It is surrounding us in a roughly spherical cloud, a cloud that is dwarfing everything that we can actually observe. We are living inside of this vast and invisible structure. We are like deep-sea creatures that are inhabiting the illuminated zone of an ocean that is extending far beyond their experience. The dark matter halo is shaping the behavior of everything that is within its immense boundaries. The satellite galaxies are orbiting through this invisible medium. They are experiencing the gravitational forces from the matter that they cannot see or touch in any way. The orbital paths of our companion galaxies are tracing out something. They are tracing out the true gravitational architecture of our cosmic home. They are revealing the presence of the dark matter. They are doing so through their own motions in space. Recent computer simulations have suggested that our dark matter halo, it is containing thousands of smaller subhalos within it. These are dense concentrations of the invisible matter, concentrations that are moving through the larger structure. They are moving just like schools of fish that are swimming through the ocean. Some of these subhalos might be massive enough to capture normal matter and to form the small satellite galaxies that we are seeing. Others are remaining forever dark, consisting entirely of particles that are never interacting with any photons at all. This extended dark matter envelope is determining our galaxy's relationship, its relationship with the broader universe that is around us. The halo's gravitational influence is reaching out to capture the gas that is falling in from the intergalactic space. This is providing the raw material for our continued star formation. it is also shielding us from some of the violence of the cosmic environment. It is deflecting the high-speed particles and the smaller objects that might otherwise disrupt our galaxy's delicate structure. The boundary that is between our dark matter halo and the intergalactic space is remaining poorly defined. The halo's density is gradually decreasing with its distance from our own galactic center in the galaxy. It is eventually becoming so thin that it is merging. It is merging imperceptibly with the general dark matter background, the background that is filling all of the space in the universe. But even this enormous and invisible structure is representing just one component of an even grander and more complex cosmic architecture. Our own galaxy is not the stable and perfectly balanced disk, the disk that most people are imagining it to be. Instead, our cosmic home is wobbling and it is flexing. It is flexing just like a spinning coin would do. It is slowly losing its momentum over time as it spins. The outer edges of our own galactic disk are warping. They are warping up and down, and they are creating ripples. Ripples that are propagating inward toward the center of the galaxy. They are like the waves that are on a disturbed pond. This warping motion is representing one of the most dynamic and one of the most surprising aspects of our galactic structure. Recent observations that are using variable stars of different ages, they have revealed that our galaxy's warp is precessing. It is precessing, or it is rotating in a backward direction. It is doing so at roughly 1 to 2/100ths of a degree. It is doing so every single million years of time. This is meaning that the warp pattern itself is slowly rotating. It is rotating around our own galactic center in the opposite direction from our own star's orbital motion. What is it that is causing this strange wobbling motion? The culprit in this case appears to be our own dark matter halo. Computer models have suggested that our invisible halo, it has a slightly flattened shape just like a football. It is not a perfect sphere as we had once thought. As our own stellar disk is rotating within this oblate dark matter distribution, the gravitational torques are creating the wobbling motion. The wobbling motion that we are able to observe with our telescopes. Think of a coin that is spinning on a table. As the friction is slowing the coin's rotation down, it is beginning to wobble more and more dramatically. It does so until it finally falls completely flat on the table. Our own galaxy is experiencing some very similar dynamics, but instead of friction, it is the misalignment between our disk, our rotating disk, and the principal axis of our dark matter halo. This is what is creating the torques that are driving the wobbling. This galactic wobble is affecting everything that is within our cosmic neighborhood. The stars that are in the outer regions of our disk, they are experiencing some vertical accelerations. They are doing so as they are riding the warping waves. The gas clouds are getting compressed and they are getting stretched. They are doing so as the disk is flexing all around them. Even our own solar system, though it is relatively close to the center, it is participating in this slow and stately cosmic dance. The wobbling motion is also providing us with some crucial information about the distribution of the dark matter around our galaxy. By measuring how the warp is precessing over time, astronomers are able to infer the shape and the orientation of the invisible halo that is dominating our galactic mass. This is giving us one of the few direct ways to be able to probe the properties of the dark matter on the galactic scales. The satellite galaxies are contributing some additional complications to our own galaxy's wobble in space. The large and the small Magellanic Clouds, along with our smaller companions, they are all exerting their own gravitational influences. They are doing so on our own disk's structure as well. Their orbital motions are creating some additional torques that are modifying the precession rate and the pattern of our own galaxy's warp over time. This discovery is revealing that our galaxy is existing. It is existing in a constant state of dynamic evolution. It is continuously responding to the gravitational influences. influences from both the visible and the invisible matter. However, our wobbling disk is facing an even more dramatic future. A future transformation that will change it forever. 4.5 billion years from now, our night sky will be transformed. It will be transformed by one of the most spectacular events. One of the most spectacular events in all of cosmic history. The Andromeda Galaxy is our nearest large galactic neighbor, and it is racing toward us at a very high speed, at roughly 250,000 miles per hour. This colossal collection of 1 trillion of our suns, it will be colliding with our own galaxy in what astronomers call, what they call the most predictable cosmic catastrophe. The merger of these two galaxies will reshape both of them. It will reshape them beyond all of our recognition. It will be creating a new cosmic structure from the debris of our two current home galaxies. Right now, the Andromeda Galaxy is appearing as a faint smudge of light in our own autumn skies. It is barely visible to the naked eye from a dark location, despite it containing more stars than our entire galaxy. But this seemingly delicate spiral is sitting only 2.5 million light-years away. This is making it the closest large galaxy to our own. In cosmic terms, we are practically sharing the very same neighborhood. As the Andromeda Galaxy is approaching us over time, its gravitational influence will begin to disrupt our galaxy's structure. It will do so long before the actual collision occurs. Our own outer spiral arms will begin to stretch and to distort. Streams of stars will be getting pulled away from both of the galaxies. This will be creating some vast bridges of matter that are spanning the gap between the two cosmic titans. The collision itself will be unfolding over billions of years. It will be a slow-motion catastrophe that is spanning timescales that are unimaginable to our human experience. Despite it containing over 1 trillion of our suns between them, the individual stellar collisions will be remaining extremely rare. This is due to the vast distances that are separating each point of light. Instead, the collision will be resembling two clouds of fireflies that are passing right through each other, with the gravitational interactions scrambling the orbital paths of most of the stars in them. Our own sun will most likely survive this cosmic merger, though its ultimate fate is remaining uncertain for now. Computer simulations have suggested that our own solar system, it might be getting flung into the outer regions of the merged galaxy, or it might possibly be ejected entirely into the intergalactic space. The Earth may find itself orbiting a star that is wandering forever between the galaxies with no galactic home. The supermassive black holes that are at the centers of both galaxies, they will be spiraling inward toward each other during the merger. They will be eventually combining into a single gravitational monster, a monster that is containing the mass of over 5 million of our suns. This black hole merger will be releasing more energy. It will be releasing more energy in the form of gravitational waves, more energy than our sun will emit in light over its entire life, its entire 10 billion year lifetime in our galaxy. The resulting merged galaxy, which astronomers have nicknamed it Milky Way in their models. It will be bearing no resemblance to either of its parent structures. Instead of two elegant and beautiful spiral galaxies, the collision will be producing a single elliptical galaxy, a roughly football-shaped collection of stars with no organized structure, and with no prominent spiral arms at all. But this collision is representing just one single example of the violent cosmic environment that is surrounding us. Our entire local group of galaxies, which is including both the Milky Way and the Andromeda Galaxy, is rushing through space. It is rushing towards something that is massive and mysterious. It is moving at 600 miles every single second. That is representing our collective velocity toward a gravitational anomaly. An anomaly that the astronomers are calling the Great Attractor. This invisible mass concentration is lying roughly 150 million light-years away. It is in the direction of the constellations of Hydra and Centaurus. It is hidden behind the dust and the stars of our own galactic disk. The Great Attractor is exerting a gravitational pull on thousands of galaxies. It is doing so across hundreds of millions of light-years of space. Its powerful influence is reaching so far that it is affecting the motion of our entire cosmic neighborhood in the universe. It is dragging the galaxy clusters and the superclusters toward itself. It is like the debris that is caught in a cosmic whirlpool. What could possibly be massive enough to gravitationally dominate such enormous and vast volumes of space? The Great Attractor is containing the mass equivalent of tens of thousands of galaxies. Tens of thousands of galaxies that are just like our own. This mass is concentrated into a region that is roughly 500 million light-years across. This is representing one of the largest structures in the entire known universe. It is a gravitational anchor point that is shaping the motion of matter. It is doing so across the vast cosmic distances of space. The mystery of this deepens because the Great Attractor is sitting. It is sitting partially hidden behind our own home galaxy. When we are looking in that particular direction in the sky, the stars and the dust of our own galactic disk are blocking our view. They are blocking our view of whatever lies beyond that. Astronomers are calling this the zone of avoidance, a region where the observations are becoming extremely difficult. They are difficult due to the obscuration by our own cosmic home. Using telescopes that can be able to see through the dust, astronomers have been able to identify several massive galaxy clusters. They have done so in the direction of the Great Attractor, the Norma cluster and the Centaurus cluster and the Hydra cluster. All of these are contributing to the gravitational pull. The gravitational pull that is affecting our own motion through space. But even if you add up all of these visible structures, it cannot account for the total attractive force that we observe. Something else must be out there in that region. Some additional mass, possibly in the form of dark matter concentrations, or some hidden galaxy clusters is contributing to the pull. The complete inventory of the matter that is responsible for our cosmic motion. It is remaining unknown to us, hidden behind the veil of our own galaxy's obscuring material. This discovery is revealing that our galaxy is not moving. It is not moving randomly through the vastness of space. Instead, we are following the gravitational currents that have been established by the largest structures in the universe. We are all passengers that are on a cosmic river. We are being carried along by forces that are operating on huge scales that are dwarfing even our own massive galactic home. Recent observations have revealed an even larger structure, a structure that is beyond the Great Attractor in distance. The Shapley supercluster is containing thousands of galaxies, and it may be representing the ultimate destination of our cosmic journey. But the gravitational drama that is playing out in our cosmic neighborhood, it is involving more than just these distant attractors. Our own galaxy is acting as a kind of a cosmic predator. It is slowly devouring the smaller neighbors that are venturing too close. The Sagittarius dwarf elliptical galaxy is providing a perfect example of this galactic cannibalism that is in action. This small collection of roughly 4 billion stars, it is currently passing through our own galaxy's disk. It is being shredded by our own gravitational forces. It is doing so as it is attempting to complete its orbit around our own galactic center in the galaxy. Over the past few billion years, our own gravity has been stripping away. It has been stripping away most of the Sagittarius dwarf's original stellar population. Long streams of stars are now trailing behind the disrupted galaxy. They are trailing just like ribbons, and they are marking its orbital path through our own galactic halo in space. These stellar streams are wrapping completely around our own galaxy. They are creating some beautiful rings of stars that are moving moving in lockstep with their own parent galaxy's motion. The destruction of this galaxy is happening slowly but inexorably. Each time that the Sagittarius dwarf is passing through our dense galactic disk, the tidal forces are tearing away its outermost stars. The dwarf galaxy is shrinking with each and every single passage. It is losing its mass and it is gradually dissolving. It is dissolving into our larger stellar population over time. Computer simulations have suggested that within the next few billion years, the Sagittarius dwarf will be completely disappearing. Its stars will be fully integrated into our own galactic structure. This process of galactic cannibalism has shaped our galaxy's growth. It has shaped it throughout the entire cosmic history. Many of the stars that are in our own galactic halo, they have likely originated in the small satellite galaxies that our own gravity has captured and destroyed. It has done so over the past 10 billion years of time. The smooth distribution of the stars in our own halo, it is actually representing the blended remains of dozens, or even hundreds of these smaller galaxies from the past. The Large Magellanic Cloud is facing a similar fate. Though its destruction will be unfolding over a much longer time span, recent measurements of its own motion have suggested something. It may not be in a stable orbit around our own galaxy. Instead, the Large Magellanic Cloud might be making its first close approach to our own galactic neighborhood. It may have been recently captured by our extended gravitational influence. As the Large Magellanic Cloud is spiraling inward, it will do so over the next several billion years of time. Our own gravity will be gradually stripping away its outer stars, and it will be stripping away all of its gas as well. The galaxy's death throes will be feeding new episodes of star formation. They will do so in our own disk as its gas content gets incorporated. It will get incorporated into our own spiral arms. Even our smallest of the satellite galaxies are showing signs. They are showing signs of this ongoing and relentless destruction. Ultra-faint dwarf galaxies that are containing only a few thousand stars, they are bearing the scars of this tidal disruption, their elongated shapes and their disturbed stellar distributions. They are revealing the gravitational violence that they have experienced. They have experienced during their passages through our galactic environment. This galactic predation is representing a fundamental aspect of all of cosmic evolution. Large galaxies like our own are growing primarily by consuming their smaller neighbors. They are not growing by accumulating matter directly from intergalactic space. The evidence for this cosmic cannibalism is all around us. It is written in the motions and the distributions of the stars that are throughout our own galactic home. For many decades, astronomers have been debating whether our galaxy, whether it possessed one of the most common features that are found in the spiral galaxies. Most of the spiral galaxies are containing a central bar, an elongated concentration of stars that is extending outward. It is extending outward from the galactic nucleus. It is like the handle of a cosmic dumbbell in its shape. These stellar bars are playing some crucial roles. They are doing so in the process of galactic evolution. They are channeling the gas inward to feed the star formation, and they are helping to drive the spiral arm patterns, the patterns that are defining the galaxy's structure. But discovering whether our own galaxy contains such a feature, it has proven to be remarkably difficult for the astronomers. The problem has arisen from our own position that is within the galactic disk. When you are living inside of a galaxy detecting its large-scale structure, it becomes like trying to map the shape of a forest. Trying to do so while you are standing among all of the trees, dust clouds that are scattered throughout our own galactic disk. They are absorbing the visible light that is passing through them. This is creating a zone of obscuration that is blocking our view. It is blocking our view of the galactic center and making the analysis, the structural analysis, nearly impossible to be able to do. The breakthrough in this came in the year 2005. This was when the Spitzer Space Telescope used its infrared light It used it to be able to peer through the dust and to map the distribution. The distribution of the stars in our galaxy's central regions. Infrared radiation is able to penetrate the cosmic dust. It can do so much better than the visible light can. This is what is allowing the astronomers to be able to see through the material, the obscuring material that had hidden our galaxy's inner structure. It had done so for so long from our own view. The infrared observations were able to reveal a startling truth. Our own galaxy does indeed contain a central bar that is stretching roughly 27,000 light-years. It is stretching from one end to the other end. This massive stellar structure is containing billions of stars that are arranged in an elongated pattern, a pattern that is rotating as a single rigid body. It is rotating around our own galactic center in the galaxy. The discovery of this was able to explain several puzzling observations about our own galaxy's overall behavior. The central bar is helping to drive our own spiral arm pattern. It is doing so by creating some gravitational disturbances that are compressing the gas clouds as they orbit. They are orbiting around our own home galaxy over time. It is also channeling the material inward toward our central black hole. It is providing the fuel for the occasional feeding episodes. Our own galactic bar is rotating much faster than our solar system orbits. It is completing one single revolution every few 100 million years. This is meaning that the different parts of our galaxy, they are periodically lining up with the bar's gravitational influence. This is creating some waves of star formation that are propagating. They are propagating outward through our own spiral arms. The existence of the bar is also affecting our galaxy's long-term evolution. As it is rotating, the bar is slowly losing its angular momentum. It is losing it to the surrounding disk of the galaxy. This is causing it to grow longer and more prominent over the long cosmic timescales. Computer simulations have suggested that our own bar was formed. It was formed relatively recently in the galactic terms. It was probably formed within the last few billion years. This discovery has revolutionized our understanding of our galaxy's architecture. Rather than just a simple spiral galaxy with a circular central bulge, we are inhabiting a barred spiral galaxy with a complex internal structure. A structure that is driving much of the dynamic behavior that we are observing in our own cosmic neighborhood. The bar is representing just one single component of our galaxy's surprisingly complex and active interior. Across the vast expanse of our own home galaxy, approximately 3 new stars are igniting every single year, while at the same time 2 others are reaching the end of their own stellar lives in our galaxy. This cosmic birth and death cycle has been continuing. It has been continuing for over 10 billion years of time. It is gradually converting the primordial hydrogen and helium, that had filled our own galaxy. It is converting it into the heavy elements that are making up the rocky planets, and it is making up the biological life that is possible. Every single atom that is in your own body right now, except for the hydrogen, was forged in the nuclear furnaces. The nuclear furnaces of the massive stars that have lived and died. They have lived and died and scattered their processed contents. They have scattered them into the vastness of space. Star formation is not occurring randomly throughout our galactic disk. Instead, it is concentrating in the spiral arms of our galaxy. This is where the compression waves are squeezing the gas clouds. They are squeezing them to much higher densities than normal. These stellar nurseries are shining brilliantly with the light of the newborn stars that are within them. This is what is creating the bright patterns that are making the spiral galaxies, making them visible across the billions of light years of space. The most massive of these stars are containing a great deal of matter. They are containing 10 to 100 times more matter than our own Sunday, and they are burning through their nuclear fuel in just a few million years. They do so before they are exploding as supernovas. These stellar explosions are releasing more energy in just a few seconds, more energy than our own sun will emit over its entire life, its entire 10 billion year lifetime in our galaxy. The shock waves that are from these supernovas are compressing the nearby gas clouds. They are triggering new rounds of star formation in a self-perpetuating cycle. The lower mass stars, like our own sun, are burning their fuel. They are burning their fuel much more slowly over time. They are shining steadily for many billions of years. They do so before they are gradually swelling into red giants. And then they are eventually shrinking down to white dwarf remnants. These long-lived stars are providing some stable sources of energy that could potentially be able to support the biological evolution, the evolution of life on the orbiting planets over cosmic timescales, the chemical composition of the new stars that are forming. It has changed dramatically over our own galaxy's history. The very first generation of stars were formed from pure hydrogen and helium. These were the only elements that existed after the Big Bang. When these primordial stars died, they scattered their heavy elements. They scattered them into space through their stellar winds and their supernovas. Each of the subsequent generations of stars has incorporated these. It has incorporated these heavier elements into its own structure. This has gradually enriched our own galaxy with carbon and oxygen, and with silicon and iron and all of the other elements that are necessary for complex chemistry. Our own sun was formed roughly 4.5 billion years ago, and it is representing at least a third-generation star. It was built from the material that was processed through multiple cycles of stellar birth and stellar death. The current rate of star formation in our own galaxy. It has declined significantly from its peak in the past. Its peak was roughly 10 billion years ago in our history. During our own galaxy's youth, the new stars were igniting. They were igniting at rates that were perhaps 10 times higher than today. This slowdown is reflecting the gradual depletion of the raw materials that are necessary for the star formation process. This is happening as more and more of the gas is getting locked up. It is getting locked up in the long-lived stellar remnants. Computer models have suggested that our own galaxy will continue. It will continue to be forming new stars for many billions of years, but it will be doing so at steadily decreasing rates. Eventually, the star formation in our galaxy will cease entirely. This will happen when our galaxy has exhausted its supply of gas and dust. This stellar recycling process is operating on the scales that are encompassing our entire galactic home. The boundary of our own galaxy is refusing to stay put. For many decades, the astronomers had assumed that our galaxy's stellar disk, it was ending at a very well-defined edge, an edge that was roughly 50,000 light-years from the galactic center. Beyond this particular point, they had expected to find only empty space that was populated by the occasional globular cluster, or by the occasional stray star that was wandering through. But recent observations have shattered this comfortable assumption. In 2018, some astronomers were using data from the Gaia space mission. They discovered some stars that were belonging to our galactic disk. They found them at distances of 84,000 to 103,000 light-years. They found them from the center of our own galaxy. These distant stellar populations are existing far beyond what was once considered the absolute limit of our galaxy's structure. This is extending the known boundaries of our cosmic home. It is extending them by tens of thousands of light-years. Even more surprisingly, some follow-up studies have pushed the detection of these disk stars out to even greater distances that are approaching 130,000 light-years. 130,000 light-years from our own galactic center. This means that our own galaxy is stretching significantly farther than the canonical 100,000 light-year diameter, the diameter that the astronomers have been using for over a century. But the stellar disk is representing only a part of the story. Recent measurements of our galaxy's own dark matter halo They have suggested that it is extending nearly 2 million light-years. 2 million light-years from our own center of the galaxy. This is 20 times farther than the visible stellar populations. The true boundary of our own galactic domain is reaching. It is reaching almost halfway to the Andromeda Galaxy. The Andromeda Galaxy is our nearest large galactic neighbor. This extended structure is creating a puzzle for our models of galaxy formation and of their evolution. How can our galaxy be able to maintain its organized stellar populations? How can it do so at such enormous distances from the center? The orbital periods of the stars in these outer regions, they are exceeding 1 billion years in their duration. This is meaning that they have completed only a handful of orbits since our own galaxy first formed. The discovery of this extended structure is also raising some questions about where our own galaxy is ending and where the intergalactic space is actually beginning. If our own dark matter halo is stretching 2 million light-years, while Andromeda's halo is extending a similar distance, the two halos may already be touching each other or overlapping. In this sense, the collision between our two galaxies, it may have already begun, even though the stellar populations, they will not be merging for another 4 billion years. The gravitational interactions with the satellite galaxies, they may be helping to explain some of these extended stellar populations. As our own gravity is tearing apart the smaller companion galaxies, their stars are getting scattered across some vast volumes of space. Some of these disrupted stellar streams could be able to account for the stars. The distant stars that we are now observing in our galaxy's outer regions, the continuing expansion of our own galaxy's known boundaries. It is reflecting the improvements in our observational technology, and it is reflecting the improvements in our data analysis techniques. Each new generation of the telescopes and the space missions, it is revealing some previously hidden components of our cosmic home. It is pushing the frontiers of the known ever farther outward. This pattern is suggesting that our galaxy's true extent, it may be even larger than our current measurements are indicating. Invisible magnetic highways are spiraling through our own galaxy. They are channeling the flow of the charged particles. They are doing so across distances that are dwarfing entire solar systems. These galactic magnetic fields, though, they are thousands of times weaker than a simple refrigerator magnet that you might have. They are extending across the full 100,000 light-year expanse. The expanse of our own cosmic home, the Milky Way galaxy. They are threading through the interstellar space like cosmic power lines. They are guiding the motion of the electrically charged gas, and they are influencing the birth and the death of the stars. They are doing so throughout our own galactic neighborhood. The magnetic field lines are following the spiral pattern. The spiral pattern of our own galaxy's overall structure. They are wrapping around our own galactic center in great sweeping arcs that are mirroring the distribution of the spiral arms. This alignment is occurring because the rotation of our galaxy, it is stretching and it is twisting the magnetic field. It is much like wringing out a wet towel is causing the water to align along the spiral patterns in the fabric. These magnetic highways are playing some crucial roles. They are doing so in the galactic dynamics that are remaining invisible to our own everyday experience of the universe. Charged particles which are including the cosmic rays. The cosmic rays that are accelerated by the supernova explosions, they are following the magnetic field lines as they are traveling. They are traveling through the vastness of space in our galaxy. High-energy protons and electrons are spiraling along these invisible tracks. They are sometimes journeying for thousands of light years. They do so before they are encountering any obstacles that can deflect their paths. The magnetic fields are also influencing the process of star formation. They are doing so by providing a support pressure that is helping to resist the gravitational collapse in the gas clouds. When the magnetic field lines are becoming tangled or compressed. They can either enhance or they can inhibit the formation of the new stars, depending on the local conditions. This magnetic regulation is helping to explain why the star formation, why it is occurring in some regions of our own galaxy, while at the same time it is leaving other regions relatively barren. Recent observations that have been made from our space missions, they have begun to map our galaxy's magnetic structure. They have done so in an unprecedented level of detail. The European Space Agency's Planck mission has measured the polarization of the light from the interstellar dust grains. This has been revealing how these particles are aligning. They are aligning with the local magnetic field direction. The resulting maps are showing a complex web of magnetic structures that are threading through our own galactic disk. These magnetic fields are originating from the motion of the electrically conducting gas that is within our galaxy. As the clouds of the ionized hydrogen are moving through space, they are generating some electrical currents that are producing the magnetic fields. The rotation of our own galaxy is then amplifying and organizing these fields. It is organizing them into the large-scale structure that we observe today. The strength of our own galaxy's magnetic field is varying. It is varying dramatically from one region to another. Near the galactic center, the intense stellar activity and the presence of our own supermassive black hole are creating something. They are creating magnetic field strengths that are hundreds of times greater than the galactic average that we see elsewhere. In the quiet regions that are between the spiral arms, the magnetic field is becoming so weak that it is barely influencing the behavior of the charged particles. Magnetic reconnection events where the field lines are breaking, and they are reconnecting in different configurations. They can be releasing enormous amounts of energy across interstellar distances. These magnetic phenomena are connecting our galaxy's structure. They are connecting it to the broader electromagnetic environment of the universe. Our own galaxy is existing as one single ordinary member of an almost incomprehensibly vast cosmic population. Recent estimates have suggested that the observable universe, it is containing roughly 2 trillion different galaxies. Each one of them is a massive collection of stars, gas, and dark matter. 2 trillion is a number that is exceeding every single previous estimate. It is exceeding them by absolutely enormous margins. This is revealing that the cosmos is harboring far more galactic cities, far more of them than anyone had ever imagined. Our own Milky Way is representing less than 1/trillionth of the total galactic population of the universe. Among this vast multitude of all of the different galaxies, our own galaxy is ranking as decidedly average in most respects. With roughly 400 billion stars, we are sitting near the middle of the galactic mass distribution. Many of the galaxies are containing fewer stars than we do, while other galaxies are dwarfing us completely in their size. The largest of the elliptical galaxies are harboring over 1 trillion stars. This is making our own cosmic home look very small by comparison. Our own galaxy's structure is also proving to be typical. It is typical for the spiral galaxies throughout the entire universe. Roughly 60% of all of the galaxies are displaying spiral patterns that are similar to our own home galaxy. They have central bulges, and they have flattened disks, and they have prominent and beautiful spiral arms. We are belonging to one of the most common types of cosmic architecture. We are sharing our structural similarities with billions of other spiral galaxies that are scattered all across the vastness of space. However, our own galaxy does possess some unusual characteristics that are setting it apart from the cosmic norm. We are living in a relatively quiet galactic neighborhood. We are far from the dense galaxy clusters where the violent interactions and the mergers are occurring much more frequently. Most of the galaxies in the entire universe are inhabiting They are inhabiting much more crowded environments than we are, where the gravitational encounters are regularly disrupting the galactic structure. Our own galaxy is also appearing to be unusually isolated. It is isolated compared to most of the other spiral galaxies. While we do have our own satellite galaxies around us, and we will eventually be colliding with the Andromeda galaxy, many of the spiral galaxies are existing in small groups, or they are existing in clusters where multiple large galaxies are interacting gravitationally. This relative isolation has allowed our own spiral structure. It has allowed it to remain stable for many billions of years. The chemical composition of our own galaxy is falling. It is falling within the normal ranges for the spiral galaxies of a similar mass and a similar age to our own. The abundance of the heavy elements in our stellar populations. It is indicating that we have experienced some typical rates of star formation and of stellar recycling. We have experienced this over the long cosmic timescales. Our own sun's metallicity, though it is slightly enriched, it is enriched compared to the galactic average of other stars. It is representing the conditions that are found throughout many spiral galaxies. Perhaps most remarkably, our own galaxy is appearing. It is appearing to be forming stars at rates that are consistent with the other spiral galaxies in the current epoch. We are belonging to what the astronomers are calling the Green Valley. We are in the Green Valley in the galaxy color magnitude space. This is indicating that our own star formation rate is gradually declining. It is declining as we are consuming our available gas supply. This comparison is revealing both our own cosmic significance, and it is also revealing our own insignificance at the same time. While our own galaxy is containing hundreds of billions of stars, and it is spanning hundreds of thousands of light years of space, it is representing just one single typical example. A typical example of the galactic architecture that is repeated all across the entire observable universe. The existence of 2 trillion of these other galaxies. It is raising some profound questions about the likelihood of life and intelligence elsewhere in the cosmos. Our own galaxy is not just drifting randomly through the empty space, but instead it is traveling along one single strand of the largest structures in the entire known universe. The cosmic web is representing the ultimate architectural framework of all of creation. It is a vast network of dark matter filaments that are connecting the galaxy clusters across billions of light years of space. These invisible highways are channeling the flow of matter and energy. They are doing so on the largest scales that are imaginable. They are creating a kind of a spiderweb pattern that is spanning the entire observable universe that we can see. Our own galaxy is sitting embedded within one of these cosmic web filaments. It is following a predetermined path that has been established by the gravitational influence of the dark matter concentrations that were formed in the very early universe. It is like a train that is traveling along some invisible tracks. We are moving through space, and we are being guided by forces that are operating on scales that are dwarfing even our own galaxy. The cosmic web filaments are forming the backbone of the cosmic structure. They are containing roughly 60% of all of the matter in the universe. These filaments are stretching between the massive nodes where thousands of galaxies are clustering together. This is creating a network that is resembling the neural pathways in a vast and grand cosmic brain. Empty voids that are containing almost no matter at all. They are separating the filaments just like the spaces that are between the brain cells in our own minds. Computer simulations have revealed that this web-like structure, it has emerged naturally from some tiny density fluctuations that were in the very early universe. Over billions of years, gravity has amplified these initial irregularities. It has caused the matter to flow along some preferential directions, and it has created the filament pattern that we are observing today. The galaxies were formed at the intersections of these filaments, and they were also formed along the lengths of these dark matter highways. Our own local group of galaxies, which is including both the Milky Way and the Andromeda Galaxy, is traveling along a single filament, a filament that is extending toward the Virgo cluster. This is a massive collection of over 1,300 galaxies. It is located roughly 54 million light-years away from us. This filament is providing the gravitational framework, the framework that is guiding our own motion through space, and it is connecting us to the broader cosmic structure. The filament that we are inhabiting is containing not only galaxies, but also vast reservoirs of hot and ionized gas that is filling the spaces between our galactic neighbors. This intergalactic medium has been heated to temperatures of millions of degrees, and it is glowing. It is glowing faintly in the X-ray part of the spectrum, and it is providing the raw material for the continued galaxy formation and for the continued galaxy growth over the cosmic time. Recent observations have begun to map the cosmic web. They have begun to map it directly by detecting this hot gas and by measuring the subtle gravitational lensing effects that are created by the dark matter filaments. These studies are confirming that our own galaxy is indeed traveling. It is traveling along one of the universe's fundamental structural components. The cosmic web is also influencing our own galaxy's evolution. It is doing so by regulating the flow of matter between the environments, the galactic and the intergalactic environments in space. The gas that is falling into our own galaxy along the filament. It is providing the fuel for the continued star formation, while the galactic winds that are driven by the supernovas and by the stellar radiation can escape along these same pathways. This cosmic context is revealing that our own galaxy's history and its future are remaining intimately connected. They are connected to the largest scales of cosmic organization. If we could somehow be able to travel outside of our own galaxy and then look back at it from a great distance, we would be able to witness one of the most beautiful sights in the entire universe. Our own cosmic home would be appearing as an elegant spiral galaxy. Its sweeping arms would be glowing with the light of billions of stars that are arranged in some graceful curves that are extending outward from a bright and central bulge, blue-white clusters of the young and massive stars. They would be illuminating the spiral arms like Christmas lights that are strung along the cosmic highways, while the warm yellow glow of all of the older stars, it would be filling the spaces between the arms with a more subdued radiance. The central bar-shaped structure would be stretching across the galaxy's heart, its elongated concentration of the ancient stars. It would be rotating slowly around the supermassive black hole. The supermassive black hole that is at our own galactic core. Dark lanes of cosmic dust would be tracing the spiral arms. They would be creating some intricate patterns of light and shadow, patterns that are revealing the galaxy's own internal structure and its ongoing star formation activity at the same time. From this impossible and external vantage point, we could be able to observe the faint halo of the globular clusters, the halo that is surrounding our own galaxy like fireflies that are around a bright campfire at night. These ancient stellar cities would be appearing as tiny points of a very concentrated and beautiful light. Their orbits would be tracing out the true three-dimensional shape of our own galactic home. The extended and vast dark matter halo would be remaining invisible. Its presence would only be detectable through the gravitational effects that it has on the nearby objects. Our own galaxy's disk would be appearing to be remarkably thin. It would be thin when it is viewed in an edge-on orientation. It would be resembling a kind of a cosmic pancake, a pancake with a thickness that is less than 1/50th of its diameter. The galactic warp would be clearly visible from this perspective. It would be showing how our own outer regions are bending. They are bending up and down just like a warped record album. A warped record album that is slowly spinning in space. The satellite galaxies would be clearly visible as smaller companions that are orbiting around our own massive galactic home, streams of stars that have been torn from these disrupted neighbors. They would be tracing some delicate arcs across the sky. They would be recording the gravitational violence that has been inflicted by our own galaxy's powerful tidal forces. The approaching Andromeda galaxy would be looming in the distance. Its own beautiful spiral structure would be clearly visible against the dark cosmic background of space. But we will never be able to enjoy this external perspective. We will remain forever trapped within our own galactic home. We are like creatures that are living their entire lives inside of a vast and grand cathedral. We are able to examine the individual architectural details, but we are never able to step outside of the cathedral and to appreciate the building's complete design from a distance. This limitation is what is defining the human condition. It is defining it on the vast and grand cosmic scales. We are inhabiting something that is far grander than ourselves, yet we can never fully comprehend its beauty or its complexity. This is because we cannot escape our own position that is within it. We must be able to piece together our own galaxy's appearance. We must do so from the fragments and the clues that we can gather. We are like archaeologists who are reconstructing an ancient temple, reconstructing it from the scattered stones that they can find. Despite this particular limitation that we have been able to succeed in mapping our galactic home. We have done so with a remarkable and impressive accuracy through our careful observations and our computer simulations, and through our comparisons with the external galaxies. We have been able to learn that we are inhabiting one of the universe's most magnificent and beautiful structures. Our own galaxy is spanning over 100,000 light years. It is containing 400 billion different stars, and it is participating in the grandest cosmic dance imaginable. We are the citizens of infinity in this vast cosmos. We are the residents of a cosmic city that is beyond all human comprehension. We are forever seeking to understand our own place in this vast architecture of the universe.